Yeah, hello students. So today we are going to take another important chapter of quantitative aptitude, which is called time and distance, or time, speed and distance. So let's see some of the common scenario where we find usage of term called time and distance. So let's say students, you are traveling from Delhi, right? So this is Delhi to Mumbai, right? So Delhi to Mumbai is approximately 1000 kilometer. You can take either your own car, you can take train, or you can take like flight. Fine. So let's say you start from Delhi and you travel by car, and it take like around 36 hours to reach Mumbai. Fine. And in case you travel by train, let's say you boarded Rajdhani, so it take around 24 hours, or yeah. So let's say it take 24 hours to reach Mumbai from Delhi, and let's say you boarded a flight, right, from Delhi to Mumbai, so it take 1 hour. Fine. So from this data, like we know that Delhi to Mumbai distance is fixed, right? It's 1000 kilometer, but the different mode of travel is giving us a different time duration, right? So we can estimate the speed that each of these different mode of transport has. For example, this car. So this car has a speed of approximately 1000 by 36 kilometer per hour, right? This train, so it has speed of around 1000 by 24 kilometer per hour, and this flight has speed of 1000 kilometer per hour. So from it, like we know that traveling by flight or air is fast as, and traveling by car is slow as, right? So this time, speed and distance, so these are the some of the terms which we normally hear on daily basis, right? Right. So okay, so let's see some of the definition and formulas of this chapter, and then we will see the application of these concepts, right? So first of all, this is the important equation, right? So this means that speed multiplied by time is equal to distance, right? So between Delhi and Mumbai, so we know that the distance is like 1000 kilometer, right? And speed for train is like 1000 by 24 hours, and time taken is like, this is kilometer per hour, and time taken is like 24 hours. So speed into time, and this product is equal to the distance covered from one point to another point. Fine. So this is the most important formula that you need to remember. Second thing that you need to take care in these kind of questions is sometimes it is given that one of the term it is given in meter per second, and another terms are given in kilometer or in hours, right? So basically you need to apply basically conversion formula, which is like 1 kilometer per hour equal to 5 upon 18 meter per second. So this is important conversion formula, because sometimes question might be tricky that one term is in meter per second in meters and the speed is in kilometer per hour. So basically you need to convert the speed into meter per second, so that all the units are in same, right? So let's see the concept of relative speed. Okay, so let's say so two body are moving in opposite direction at speed of s1 and s2. So let's say there are two cars, one car and second car. Fine. So they are moving toward each other. So first car speed is like s1 kilometer per hour, second one speed is like s2 kilometer hour. So the relative speed, that mean um, basically for example I'm driving this car, and right, so for me the relative speed with respect to s2 is like s1 my speed and s2 the incoming opposite incoming speed, so s1 plus s2. And in case like if both the body are moving the same direction, that means that let's say first and second car is there, so first car is like moving at s1, second car is moving at s2, right? So the relative speed of let's say s1 will be basically it will be s1 minus s2. So there will be a difference because it is taking the reference of the second car, so that's why the relative speed become s1 minus s2. Fine. So apart from speed, there's also a concept called acceleration. So acceleration is basically a rate of change of speed. Fine. So basically let's say instead of constant this 1000 upon 24 kilometer per hour, so let's say this the train, it increases its acceleration. That means it, let's say this number is approximately 40 kilometer per hour, right, roughly. So it say that okay, I want to reach it in earlier time, so I need to increase the speed. So it increased the speed from 40 kilometer per hour to 60 kilometer per hour. So that the rate of the change over the given period of time, so that term will be called acceleration. And the final speed that can be written as initial speed, which was earlier 40 plus acceleration. So the acceleration is basically the rate of change into time. Fine. So okay, so let's see the application of this speed and time, speed and distance, right? So one of the application is in trains. So basically let's see the major concepts. When the train is crossing a moving object, the speed has to be taken as a relative speed of the train with respect to the object. Okay, so basically what train is there, this is the train, right? And this is single object. Let's say up there is one pole standing, right? So train is crossing this object. So basically sometime we need to find out like how much time it needed to cross this pole, right? Or let's say this is not a static object, it is like it's a moving person, so there is a speed, its own speed also, right? So different cases are given. So basically we need to find out the relative speed. That means if they are moving in the same direction, if it is static or not. If it is static, then this speed will become 0, right? If it is not, then it become, let's say it become u kilometer per hour, it is moving at v kilometer per hour. Fine. And okay, so basically there is a length of train also. Let's say its length is L. So there might be some length of this object. For example, it might be a platform, so there might be length of this platform also. So basically the time taken to cross this particular object, it might be platform, it might be a pole, or it might be a moving car. So it can be this whole can be written as like time taken to cross this particular object is like a plus b. A is basically the length of train, b is like length of that particular object. For example, if it's a platform, then it becomes the length of the platform. If it is a pole, then this length is negligible and we can take it as 0. And this is like upon u plus b, so speed of train, and as well as like speed of the object. So this plus or minus, it can be like if both of objects are moving toward or like or to moving along or opposite direction. Fine. So let's see another application of time, speed and distance. So second is like boat and stream. So we know that in a river, right? So river has a certain flow direction. Okay, and let's say there's a boat, right? So boat is moving in the river. So basically when this boat, which has a speed of, let's say u, or s1, right, and the river has a speed of s2. So when both of them are moving in the same direction, that means that boat is moving downstream. So the speed is like a relative speed is called s1 plus s2, because this flow of river assists in in the speed of in moving the boat faster. And when this boat is moving against the stream, so basically this flow of river, it will decrease the speed of the river, it will decrease the speed of the boat. So ultimately the speed will become s1 minus s2. And sometimes it is given that basically these terms are called like upstream speed and downstream speed, and sometimes it is given that downstream speed is given and upstream speed is given, and we need to find out the speed of the boat and speed of stream. So that can be easily find out like speed of boat become like 1/2 into a plus b, and speed of stream become 1/2 into a minus b. So students, these are all the concepts of time, speed and distance, and we have seen their application in trains as well as in boat and stream. So let's understand these concepts with the help of some of the examples. Okay, all right. So okay, so basically a farmer travel a distance of 61 kilometer in 9 hours. So okay, so farmer is traveling 61 kilometer in 9 hours, right? So there are 61 kilometer and there is a 9 hours, and he traveled partly on foot and at 4 kilometer per hour, and partly on bicycle at 9 kilometer per hour. All right, so basically some of the distance, let's say d is travel via foot at 4 kilometer per hour, and like 61 minus d is on bicycle at 9 kilometer per hour. So basically we need to find out the distance travel on foot, so we need to find out basically d. So okay, from the formula we know that speed into time equal to distance. Fine. All right, so basically we know that time equal to distance by speed. Fine. Okay, so the time taken, let's say here is t1 and this one is t2, right? So both time t1 plus t2 is the duration of the journey, right, which is 9 hours. Fine. So basically 9 hours equal to the first time t1, which is like d upon 4, and second time t2, which is like 61 minus d upon 9. Fine. So basically when I solve this, so it become 9d plus 244 minus 4d. So okay, so when I multiply this, it become 324 equal to 5d plus 244. So okay, ultimately when I solve this, it come out to be 16 kilometer. So the distance travel on foot is 16 kilometer. Okay, so let's see the next question. So in a flight of 600 kilometer, so a journey overall journey is given like 600 kilometer. So basically an aircraft was slowed down due to bad weather. Its average speed for the trip was reduced to 200 km per hour, and the time of flight increased by 30 minutes. Okay, so here basically you need to see that it is given in minutes and other things are given in kilometer, right? So basically we can convert it into hours. It will be like 0.5 hours. So it is given that due to some bad weather, there is a reduction in speed as well as reduction increase in time. Fine. So let's see how much is the reduction in speed. Fine. So let's say earlier this aircraft was traveling at s speed, right? and now basically it is traveling at s minus 200. Fine. And earlier this aircraft was taking t time, and now it's taking as t plus 0.5. Fine. So let's say if I compare the difference of speed, like initial speed, fine, and final speed, so let's say the difference become 200, right? That initial and my final speed, and the reduction in time is like basically 600 upon t minus 600 t plus 0.5. Fine. So basically it become 600 and sorry 200 600 t minus 600 t plus 1 by 2, and okay, if I divide, like, so it is like 3 and 3, so 1 equal to 3, 1 by t minus it become 2 2t plus 1, right? So now I have basically equation like t into 2t plus 1, right? And I have here I have okay, so I have around 1 equal to 3, right? So I have 2t square plus t minus 3 equal to 0. So I need to find out the roots of this particular equation. So when I solve this, the t it come out to be 1. So the duration of flight it become 1 hour. Okay, so let's see the next question. So basically A walks around a circular field at the rate of 1 round per hour, while B runs around it at the rate of 6 round per hour. They start in the same direction from the same point at 7:30 a.m. They shall first cross each other at, okay, fine. So we know that there is a circular track given, and A is running in the same direction and B is also running in the same direction, fine. But A is like it is taking basically 1 round per hour, and B is more fast, like A is walking and B is running, so B is faster, so it is taking around 6 round per hour. Okay, so now basically let's see the relative speed of basically both. So because both of them are like moving toward the same direction, so the relative speed it become 5 rounds per hour, fine. So, and basically the time taken will be 1 by 5 hour, fine. So that will be around 12 minutes. So that means that both of them crosses each other in 12 minutes. So let's say they start at 7:30, so after 12 minutes, that means at 7:42 they will meet again. So A is the correct answer. So let's see the next question. So a train 125-meter long passes a man. So okay, one train is given, is a 125-meter long, and it is passing a man who is running at 5 km per hour. So this person is there, so 5 km per hour he is running. So it crosses in 10 seconds, right? So we need to find out the speed of the train. So we are given the length of the train, we are given the basically time taken to pass this thing, right? So okay, fine. So basically as we remember from the formulas that we have seen earlier, the time taken will be speed of the train, and okay, so 5 and we don't okay, we don't know the speed of the train, right? So let's say speed of the train is x kilometer per hour, right? So x minus 5 kilometer per hour, right? So basically x minus 5 kilometer per hour, right? Correct. But here one thing we need to see is like the speed is given in kilometer per hour, but the other things are given in meter and seconds, right? So basically we need to convert this kilometer per hour into meter per second. So how we are going to do this? We are going to multiply by 5 upon 18, right? So that will come 125 x minus 5 upon 18. Fine. T is like 10. So 125 is 25. So 25 into 18 x minus 5. Fine. So basically x minus 5, that is like 25 into 18 upon 10. Okay, so 9 by 5 and 5, so it's like 45, and x plus x is 50. So x is basically 50 kilometer per hour. So B is correct answer. So let's see another question. So here a 270 meter long train is running at the speed of 120 kilometer per hour, crosses another train running in opposite direction. So there are two trains given, right? So train 1 is 270 meter, and train 2 we don't know length, and this speed is like 120 kilometer per hour, and this speed is like 80 kilometer per hour. Fine. And they crosses each other in 8 seconds, right? So we know the formula is like 270 plus L. Fine. And because they are opposite each other, so they 200, and because it is in kilometer per hour and other things are meter per second, so we are going to multiply it by 5 upon 18. Fine. And this time is 8 seconds. Okay, so it become 8 into 1000 upon 18 equal to 270 plus L. Fine. So now we have 9 4 and 400,000 upon 9 equal to 270 plus L. Okay. So okay, so basically here as we can see that so L become 4,000 by 9 minus 270. So this will be the length of the second train. Okay. So okay, so let's move to next question. A boat can travel with a speed of 13 km/h in still water, right? So we know that S1 is 13 km/h, and the speed of stream is 4 km/h. S2 is 4 km/h, and find the time taken by boat to go 68 km downstream. Okay, so the relative speed, basically they are both moving in the same direction, right? Because it is going in downstream, right? So it will become 17 km/h, and the distance is given is like 68 km. So the time taken is like 68 by 17, which is like 4 hours. So let's see the next question. A man can row at 5 km/h in still water. Okay, if the velocity of current is 1 km/h and it take him 1 hour to row to a place and come back. So basically so this is like a stream, so which is like 1 km/h, and this person is there on the boat. So first he is going from A to B in downstream, and second is coming from B to A in upstream, right? So basically he's covering a distance of D, right? Let's take a variable called D. So and it taking a total of 1 hour. to row from A to B and B to A, right? Or all right. So basically, in the first case, the relative speed, it become 6 km per hour in downstream, right? 6 km per hour, and upstream become 4 km per hour. So basically 1 hour which is taken, that is like basically d upon downstream is 6 plus d upon 4, so it is like 12, okay, and 2 and 3 5d. So d is like 12 by 5, which is like 2.4 kilometer. So A is correct answer. Okay, so students, with this we come to end of this chapter, time, speed and distance. In case you have further queries, like you can use our forum or you can write to us. Okay, thanks a lot, bye.